Page 67. 2. Photography. Stereophotogrammetry allows to detect the measurements of an object from its photographic image. Therefore, a photogrammeter must be, above all, master of the photographic language. Previously we talked about relief finalized with reference to the graph, but already the same photographic recovery should be finalized. Conditions necessary to photograph an object are knowledge of the object and therefore clear ideas on what you want to photograph, mastery of the camera and therefore knowledge of its limits and its possibilities. A first exercise recommended to the students of the architectural photogrammetry course consists in the photographic documentation of a building. The technical photographic language requires the greatest amount of information in the least number of frames. 2.1. The stenopic form. The simplest and cheapest camera is made up of a light-tight container with two parallel walls. By making a small hole on one of them, the upside-down image of the objects visible through it will be projected. For a good image sharpness, which can be fixed on photosensitive material, the hole must have a sharp edge and a sufficiently small diameter, less than a millimeter, but not so much as to cause diffraction phenomena. For those who have a good knowledge of descriptive geometry, the pinhole camera represents an excellent research tool. In fact, being without lenses, it respects the hypothetical straight path of the rays. The negative of this machine does not need any enlargement since, by increasing the size of the room, making it habitable, it is possible to have a large image format. The shooting angle can become small or large, symmetrical or asymmetrical, according to the needs, thanks to a suitable positioning of the image holder plane with respect to the hole. Page 68. By varying the inclination of the image holder plane, with respect to the one containing the hole, it is possible to obtain straightened or deformed images at will. On the other hand, it should be borne in mind that, due to the small size of the holes, the projected image is not very bright and, to be photographically fixed, it takes a long time, from a few minutes to several hours. 2.2. The sensitive material. We assume here that the photosensitive material is made up of a support, opaque or transparent, to which a layer of light-sensitive granules adheres. By projecting an image onto this layer, each granule will receive a certain amount of light. The material, thus impressed, is first immersed in a development solution, in which the granules undergo a blackening process dependent on the quantity of light received, later, in a fixing solution, in which the process is blocked. We define the image obtained as negative, in it the illuminated areas appear dark, while the shaded areas appear light. Captions. To test images of stereometric chambers, with pinhole, made by students of the architectural photogrammetry course. In the first case, the chamber was made of wood and the pinhole was obtained by drilling tin foil, applied on an opening of about 1 centimeter. The image was fixed directly on sensitive paper, whose low sensitivity required several hours of exposure. In the second case, the chamber was made of metal and the pinhole was obtained by crossing 4 pieces of razor blade in order to guarantee its sharp edge. Kodaith film, with normal development, was used as sensitive material to obtain the positive from contact printing, while the exposure time was about 5 minutes. Note, not only the unlimited depth of field, but also the great depth of focus, in fact the curvature of the railing, in the foreground, is due to deformation of the sensitive support. Page 69. We define the image obtained as negative, in the light areas appear dark, vice versa the light areas appear dark. If, instead of fixing the developed image, the blackened granules are eliminated with a suitable solution, it is possible to expose the material to white light, to obtain, through a further development process, what we call slide, in which the light areas appear light and the dark ones are dark. Finally, we define positive or printing the image obtained from the development of the sensitive material, with opaque or transparent support, on which the negative has been projected by contact or enlargement. In this site, rather than making an analysis of existing sensitive materials, we prefer to draw attention to the importance of the choice of sensitive material according to photographic shooting. Referring to the hypothesis formulated before, we would be tempted to use, in photogrammetry, a sensitive material with very small granules and, therefore, suitable for fixing the smallest details of the image, but the choice is not necessarily wise. The sensitive fine-grained material, also used for microfilms, has low sensitivity and high contrast, therefore long shooting times and loss of detail in the shadow areas of highly illuminated subjects. Instead, by using coarse-grained sensitive material, we will be able to take advantage of greater sensitivity and less contrast, thus reducing shooting times and the possibility of fixing the various shades of gray. Finally, we must not neglect the development technique. With the same image and material used, a suitable choice of the development solution can provide us with more or less images, contrasted and with more or less fine grain. At the same temperature and development time, a more or less concentrated solution provides a greater or lesser contrast of the image. With the same temperature and solution, an increase in development time allows to improve the quality of underexposed negatives, etc. Page 70. Captions. In photogrammetry, the choice of the photographic point takes on particular importance. The use of wide-angle lenses, in the illusion of increasing the accuracy of the survey with close-up shots, can compromise the acquisition of all the information necessary for the return. Often it may be preferable to shoot at a great distance, with long focal lenses, and use the same shooting point for the survey of the environment, with wide-angle lenses. Page 71. 2.3. The target. Replacing the pinhole with a lens, consisting of a system of lenses, has the big advantage of increasing the brightness and definition of the projected image. But it is necessary to quickly deal with what we might call the downside. Having to go through a system of lenses, the beam of rays projecting the image undergoes a series of deviations, which only theoretically respect the laws of geometric optics. The image will be subject to all those deformations, which go under the name of aberrations: longitudinal chromatic aberration, spherical aberration, astigmatism, etc., and that the manufacturers will be able to make minimal but not cancel. The distance between the lens and the sensitive surface must be varied according to the distance of the object to be photographed. Focus, when the latter becomes maximum infinite. It is minimal and takes the name of focal distance. Page 72. Captions. Left, a nocturnal photographic shot of Jerusalem from the Mount of Olives. In this case, the Mosque of Omar was identified both by using telephoto lenses and by exploiting the particular night lighting. Right, two panoramas of Jerusalem taken almost simultaneously. In the first case, the exposure meter was turned towards the buildings. In the second, however, it was turned towards the sky. The results clearly differ despite the light conditions being the same. Page 73. The angle of view increases as the focal distance decreases. We will have short focal or wide-angle lenses and long focal or telephoto lenses. The cone image varies with the type of objective, and its orientation with respect to the sensitive surface is not easily identifiable. 2.4 The meter. To measure the amount of light energy emitted or reflected by an object, we use the exposure meter. In almost all cameras currently on the market, it is an integral part of the same and automatically adjusts the brightness of the image according to the exposure time or vice versa. The mechanisms on which the exposure meter intervenes, directly or indirectly, they are the diaphragm and the shutter. The diaphragm essentially consists of a hole with a variable diameter, inserted in the path of the beam of rays projecting the image. To each degree of aperture correspond numerical values proportional directly to the focal length of the objective and inversely to the diameter itself. Therefore, with the increase of the diaphragm, the brightness of the projected image is reduced. Page 74. The shutter is a mechanism that regulates the projection time of the image on the sensitive material, exposure time, and the relative values are expressed in fractions of seconds, and minutes. The exposure meter, based on the sensitivity of the film, indicates a series of diaphragm time pairs corresponding to the same amount of light. Here it is appropriate to draw attention to the different degree of illumination of the objects photographed and to the possibility that, despite the film's latitude and the use of compensating detectors, not all the information shown on the frame is legible. It is good practice, while shooting, direct the exposure meter towards those areas that present critical lighting and, if necessary, take multiple shots with the same shot but with different exposures. Page 75. Captions. Shooting with a shutter is used not only when the lighting is poor, but also when you want to delete moving objects. Left, above, an attempt to photograph, from Golgotha, the place of deposition, and, below, a shot of the same place made through visitors. The image of the latter is so moved as to appear transparent. On the right, a black cardboard, placed in front of the lens when it was opened, was removed only when the shooting field was free from unwanted subjects. In the photo of the Bethlehem grotto above, visitors appear on the left in the form of mist. In the photograph below, detail of the castle of Gioia del Colle, taken in broad daylight, the use of very low sensitivity film 8-bin and the application of the yellow filter. Page 76. 2.5. The depth of field. By observing any photograph, we realize that not only is the image of the focused object defined, but also that of objects closer or farther away. We define depth of field as the distance between the closest and the farthest object whose images have sufficient definition. It increases with increasing diaphragm, therefore with the decrease of the diameter of the hole, in line with what occurs for the pinhole. Shooting distance, understood as the distance between the lens and the object in focus. Shooting angle of the lens, more precisely, with the same frame, decreases with increasing focal distance. 2.6. Artificial lighting. In the documentation, the use of artificial lighting is always an inadvisable solution due to the alteration of the environmental values that derives from it. However, it is an indispensable element when it is necessary to correct the lighting in some critical areas of the photographed object. Captions. Left, flash shot in the Bethlehem grotto. Compared to the previous shot, the ambient lighting is clearly altered, but information that was not directly visible appears. Page 77. On the right, 3 series of shots taken by varying the diaphragm, with the same shooting distance and focal length. The focal length, with the same shooting distance and aperture. The shooting distance, with the same aperture and focal length.